Yo, what's up, everybody? Welcome back to Algebra 1. Now, we're actually almost done with this. We only have one or two more videos. I'll try to cram as much as I can, but yeah. So far we've talked about 4 videos, so far we've done 4 videos. Should have been 2, but it's okay. Hopefully they were worth it. Talked about lines, then we talked about factoring and expanding. Now we're going to talk about quadratics. So what really is a quadratic? So a quadratic is, hopefully you might have learned about polynomials in pre-algebra, right? Like, yeah, and maybe you might have learned the quadratic term before, but I'm going to be teaching you about them. So a quadratic is in the form ax squared plus bx plus c. What does that mean? So, as usual, x is the unknown, right? We're solving for x, like in mx plus b, right? We were solving for x. So in this case, we're solving for x, right? But the thing is that we have an x squared, and we have an x to the first, and we have an x to the 0th. And dealing with x squared and x cubes and stuff like that are really complicated. We're actually not going to talk about x cubes. They're called cubics. We're going to talk about those in Algebra 2. But we want to learn about the quadratics just to get a good understanding. So a, b, and c are numbers, right? Like 3. So an example of a quadratic is 3x squared plus 2x plus 1. Usually they're equal to 0. Or they can be equal to y. Okay, cool. So now, when they're equal to y, we're usually graphing them. Remember graphing? God. When they're equal to 0, we're solving for them. Now, let's say we had something like 3x squared plus 2x plus 1 equals 7. God, how do we do this? We want to, but it's equal to 0. So to make this equal to 0, we subtract 7 on both sides. Right? And we're going to get 3x squared plus 2x minus 6 equals 0. And now we have our usual quadratic. So solving them is annoying. We're going to talk about that later. But first we're going to talk about factoring them. Factoring them is simple. It's, remember, like factoring other things, right? Factoring this is a lot annoyinger, I guess. So let's say we had so when we factor them, our goal is to get them in the form PQ plus R, or sorry, PQ minus R times PQ plus sorry, no, what am I doing? PX minus R times XX, or QX minus S. And yeah, so we notice that if x equals what am I doing? Yeah, sorry. So if so wait, no, sorry. So we're first gonna learn, yeah, so first we're gonna study the basics. So we have x squared plus ax plus b. So this is the basic, where a is 1, right? So if a equals 1, then we want to factor this into x minus p, x minus r, let's say, times x minus s. Why is that the case? That's because if x equals r, or if x equals s, then we'll have it equal to 0. So we call r and s the roots of the equation of the quadratic, the roots of the quadratic. The roots is the value of x when the expression is equal to 0. So now we need to solve for r and s, and they can help us factor this. So we're going to put it in a simpler form so that we can expand it better. X plus p times x plus q. So now, if we want it set equal to this, then if x squared equals, or x squared, sorry, not what am I doing? If x squared plus ax plus b equals x plus p times x plus q, then that's equal to, if you were to expand this, we'd get x squared plus px plus qx plus pq. That's equal to x squared plus p plus q times x plus pq. And if x squared plus ax plus b equals that, then we can subtract x squared on both sides. These cancel. And that leaves us with a is equal to, actually, I'm gonna make this so that we can deal with this later too. So we're gonna have bx plus c, actually. Okay? Forgive me for changing the notation so late, but I had to, so that we can understand this better later on. So now not A now. Now it's B. So B is equal to P plus Q, and C is equal to P times Q. Okay? So this is the main thing we need to know for when A equals 1 in this quadratic. So now we're going to talk about, now we're going to do an example. So factor the quadratic x squared plus 5x plus 6. So we're looking for two numbers, p and q. What two numbers add to 5? So they'll add to this middle term, and they'll multiply to this last term. So what two numbers add to 5 and multiply to 6? So we don't know how to do that, so we're gonna use guess and check. So we're gonna try usually we look at the multiplication one, because addition is a lot more choices. So multiplication, two numbers that multiply to 6, there's 1 and 6, and there's 2 and 3. 1 and 6 add up to 7, 2 and 3 add up to 5. So it's 2 and 3. So that means that this is equal to x plus 2 times x plus 3. If you expand this, we'd get x squared plus 5x plus 6, just to check. And you can try that. Now we're going to do a little bit of a harder one. Not too hard. But what if this plus 5x became a negative 5x? Actually, what if this became a negative 6x? Ooh, so what two numbers? So now we can't just say they add to 6. They add to negative 6 now. So now what two numbers add to negative 6 and multiply to 6? Or sorry, no, wait, no. What am I doing? Hold on. Yeah, sorry, we'll make that negative 7x. So what two numbers add to negative 7 and multiply to 6? Okay, so now we can try 6, 1, 2, 3. Wait, that equals 7, that equals 5. Well, we're looking for negative 7, but this gets us 7. Wait a minute. Positive 6, right? It can also be negative and negative and negative and negative, right? Because then the negative would cancel when they multiply. So negative 6 and negative 1, when you add them, you get negative 7. And that works. Negative 2 and negative 3 gets us to negative 5. But so yeah, now that's it. So we're going to use that to our advantage. And that gets us our answer of x minus 6 times x minus 1. There you go. So, and now we're going to do one more example of this type. And now we're going to have x squared plus x minus 2. So how do we do this? So we notice that they add to 1, right? There's a 1 here. And they multiply to negative 2, right? So now sorry, instead of multiply with the x symbol, because we're using x, I'm gonna use a dot, right? So they multiply -2. So again, we're gonna look at the multiplication, right? So what number is multiplied to -2? -2 and 1. What about? Wait, that's it. Yeah. And they add 2. Wait, that's not it. Because we can also have 1 and -2. So this gets us to. So this first one gets us to -1. Doesn't work. This one gets us to 1, so it does work. So this is our solution of numbers. So now we get, so that's equal to x plus 1 times x plus -2, or x minus 2. Okay, and we can expand it to check. Now we're going to talk about harder case, and that's when a is not equal to 1. Then what do we do? Well, wait, where did I write that? Oh, sorry, no. So now we're going to talk about the case where a is not equal to 1. Then what do we do? So that's going to be so now we're going to have, I mean, it can be equal to 1, but, so a is anything. I'm just going to say a. A is anything. So we have ax squared plus bx plus c equals 0. Now, we'll use our last results as an inspiration. Oh yeah, notice that in this last one, p equals -r, q equals -s, right? And we can also say that if you multiply -1 on both sides of each equation, we get r equals -p and s equals -q. So now, back to this one. Ax squared plus bx plus c. What do we do? So now we can't have x. Notice that when we have x plus something times x plus something, then the first thing is going to be x squared always. But because we just do x times x, and that's x squared, and that's the only term with x squared. But what if we were to do something else? What if we used px plus, wait no. What if we used mx plus p times n times nx plus q. So now we have ax squared plus bx plus c equals mx plus p times nx plus q. If you were to expand this, we get mnx squared plus mqx plus npx plus pq. So now that means that a equals mn, b equals now this we can say that's mq plus np. So we have b is equal to mq plus np, and c is equal to pq. So this kind of is ugly, right? So what can we do with this? So what can we do with this? This is kind of ugly, right? We can't do anything. So, ax squared. Now, what is this? Okay, so, we can use this kind of. So let's say we, had, so now we're looking for 4 numbers. It's kind of annoying. So let's say we add factor 3x squared plus plus 7x plus 2. Okay. How do we do this? Usually, if we had like 3x squared plus 6x plus 9, we just factor out a 3 and then we'd become a normal quadratic. But we don't have that. So we're gonna try to do this. So usually we don't know what to do. So what if we can split up the 7 into two numbers? Well, what numbers? So what we're gonna do is I say to use that as an exercise and try to find the proof of what I'm about to do. So what you do is you find two numbers, so let's say P and Q, that multiply. So I'm gonna write this down here. So PQ and multiply to AC. Okay. And wait. Sorry, no. You're gonna just find two numbers. Let's say T and U. So you have TU equals AC, and T plus U equals B. Okay. So now what you do is we do in this case. So what two numbers multiply to 6 and add to 7? Well, 6 and 1, right? So instead of just writing, so now what we do is, so in this case T equals 6, U equals 1. So now we have 3x squared, and then we split up the 7x into 6x plus x plus 2. Now something cool happens. Now we look at these first two terms and these last two terms. These first two terms have a common factor of 3x. So we factor out 3x and we get x plus 2. Now these last two only have a factor of 1, so we have x plus 2. But now they both have a factor of x plus 2. So now we factor in x plus 2 and you get 3x plus 1 times x plus 2 as our answer. Now you might be thinking this is a coincidence. It doesn't always happen. Well, let's try it with another problem. Let's try it with a harder one. Let's try it with 7x squared plus 23x plus 6. I think I did that right. Let's hope. So now we want to find. Let me box this. Now what we want to do is we're gonna do so what two numbers add up to 23 and they multiply to 42? Well, the one I can think of is 21 and 2. That came right away. And they come right away usually when the more you do these, the easier they get, trust me. So T equals 21, U equals 2. We split up this quadratic again, 7x squared plus 21x plus 2x plus 6. Usually it does not matter if you do plus 2x plus 21x, but in this case I'm putting the 21x first because 7 and 21, right? Now look at the first two terms, look at the second two terms. We get 7x times, usually in the first two terms you can factor out an x as well with the coefficient. So you have 7x plus or 7x times x plus 3 plus, and then the second one you can factor out a 2 this time. So 2 times x plus 3. Now we can factor out an x plus 3 again. And no, it's not a coincidence because I just randomly thought of these numbers. Same in the first one. I just thought of these numbers randomly. But it's not a coincidence, and it's also not a coincidence that they're working out perfectly. Yeah, right now you get this. So that's our answer. Hopefully you understood what was happening in factoring. Factoring is a really annoying thing, and it comes up a lot in algebra. But you'll get through it, and yeah, see you next time. Bye.